Let me ask you. Let me ask you one question.
Okay, go ahead.
Starting the assignment. One of the assignment, which is 13.27, as for the material that we're going to use, as the mention of.
Dr. Jacob, can you lean a little closer to your microphone? I can't hear you.
Can you hear me now?
Yes, that's better. Thank you.
That assignment, they call for the, I think they said that we're going to use the IPv4 calculator. And with the way that we are doing it, that you teach us to do it is different from the way that the IPv calculator is
right
in it. So we in the reward, we I mean, a little
do you know
bit,
do you know what lab it is? What lab is it, Jacob?
I think it's 13 where we have to calculate how many ports, how many there. Let me be specific with it.
Because I can look at it and we can talk a little bit about it. I can definitely also we can do it on Thursday.
13.2. Let's see that.
This one
we had to write the one that you said we had to write the port. Let's see, where did I have it? Yes, yesterday.
Because I don't. It may have been a packet tracer. I don't think it was though.
It might be on 11. Let me let me see exactly which one is with the where.
If you can find it, we'll definitely look at it. Now, I will say this. I know the curriculum teaches a certain method, the magic number method, which is perfectly fine. There are so many different methods to learn subnetting that I really want
you. That's the one that I'm talking about, subnetting.
Yeah, but there's so many different ways to learn subnetting that I want you to make sure that you were exposed to many different ways. The one way in the curriculum, which was using the magic number, that's a perfectly fine way to do it. The 7 holy steps is good just for classful subnetting. Don't forget that. And then with BLSM, you really have to use kind of the method I taught you where you break it out based upon the size of the networks that you need. So there's different ways to do it. But which one was it? Do you know?
I think it's 11.
It must be a packet tracer then.
Yeah, it's where we have to do the subnetting, where you give us a series
1166.
Yes, it might be. Where you give us a series of okay, on that chapter.
Okay, so here it is, 11.6. Okay. So this one?
Yes, that's the one. You see, in the beginning, they said that we can use the IPv4 calculator. See, part number.
Okay. Oh, optional. Yeah, it's optional. I would say don't use it because you're not going to have it on the test. So that's why I strongly suggest you don't use it. Now, what they're wanting you to do is they're wanting you to look at this and make a determination about, all right, so let's look at this one. Let's look at what they're trying to get you to do here. Let me pull my whiteboard up because I can type it. I can write better than I can type on this. All right, so what they're wanting you to do on this very first one is they want you to be able to look and see. They want you to be able to look and see that if you had this network originally, okay, so if you had this mask originally, you were dealing actually with the network 192.168.200.0/24. So that's the network that we were originally dealing with right here. But they want you to look and say, but what if you use a new mask of 224? So remember, if you're using the new mask of 224, you had 8 host bits before, but with a mask of 224, which is actually /27, your mask at the end becomes 11100 That's 5, 6, 7, 8. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. So you got your magic number or your variable is going to be 32. So they want you to basically be able to look at this and say, if you started out with a /24, went to a /27, how many subnetwork bits are there? Well, how many are there when you borrow 3 bits?
3, 27.
3. Yep, exactly. So this first item here, the answer would be 3. Number of subnets created, well, that's 2 to the n.
33.
So 2 times 2 is 4, 4 times 2 is, so there's 3 subnet bits.
It's going to be 8.
Yep, there's 3 subnet bits. There are 8 subnets that are created. Okay, the next question is the number of host bits per subnet. Well, you look right here, how many zeros are left?
5.
5. Yep, so there's 5 host bits. And the next one says number of hosts per subnet. Well, remember our formula for that is 2 to the h minus 2 equals number of usable hosts.
32 minus 2.
Yep, so it's going to be 30 hosts, 30 usable hosts. All right, and it says network address of this subnet. Now this gets a little bit weird because what they're wanting you to do is they're wanting you to look at this IP address. So they're actually wanting you to look at 192.168.200.139 and determine what subnet it is if the mask is 255.255.255.224. The way to do that is ANDing. So you know it's going to be 192.168.200. So you take 139 and convert it to binary, and you convert 224 to binary, and you AND them together. So what would that be? So let's go ahead and say, so 139, and we'll use the long method. 139, will 128 go in? Can you subtract 128 from 139? Yes. So 1, which leaves us with 11. Can you subtract 64 from 11? No. Can you subtract 32 from 11? No. Can you subtract 16? No. Can you subtract 8? Yes.
1.
Which leaves you with 3. All right. Oh, excuse me, 8, which leaves you with 3.
3.
Can't subtract 4. You can subtract 2, and you can subtract 1. So 139 is 1000111. And we put in here 1, 2, 3, 4, 5, 6, 7, 8. And we'll see that what falls through is this 2, 4, 5, 6, 7, 8. So the subnet is actually 192.168.200.128. And that's the address here. Our first usable address would be what? Now, this is /27. So we know our variable is 32. So this goes all the way up to, this particular subnet goes up to 159. So this subnet is 128 to 159. So the first usable IP address is what?
It's going to be the 192.
192.168.
Just 129.
Yep, .129 /27. And the last usable will be .158 /27. Because we can't use the first one because it's the subnet ID. We can't use the last one because it's the broadcast ID. And that's what it asks. It says, now, what is the broadcast ID of this subnet? And that would be 192.168.200.159 /27. And that's what they're wanting you to do with each one of these. Does that make sense?
Yes, it makes sense because like you said, when they specified that optional the IPv4 address calculator.
Yeah, don't use calculator. Not for this, because real world, yes. I go to put a network in, I check against my calculator just because I don't want to make a dumb mistake. But when I'm trying to prepare for the test, no, I'm not going to do that. I'm gonna use try to learn the method I just showed you so that I'm able to do it in case I get that on the test. Okay, excellent, excellent. All right, let's go. Any other questions? Any other questions on anything in class? We've got a light number of folks today, everybody. I guess it's not a vacation week yet. That's a little rough. I have just 3 of us, but it's all good. Let's talk about ICMP, Internet Control Message Protocol.
Can you use 13.3.2? I think you already did it before, and I think it's one of the ICP.
Say again.
13.3.2.
And we're gonna look at it.
I think you already did it before in one of the class.
This one, yep. We've done that one. I think that should be in NetLabs.
Yes, it's in NetLab.
Okay, yeah. So that's in NetLab. So we could do a 13.3.2, and I can do that one and basically it's just showing you the ping commands, ping and how ICMP and Traceroute works. Yeah, 13.3.2 is inside of NetLab, so that is definitely one. By the way, for your hands-on final exam, one of the things you will need to be able to do is configure SSH on devices. So that lab's going to be very important when we get there. We will talk about it. But let's talk just a second about, how in the world did I end up back here without? Let's talk about ICMP and what it is. Every protocol stack needs a way to share messages, control messages, and also to test for connectivity. Well, Internet Control Message Protocol, ICMP, is that device for both for V4 and V6. Now, it's used in V6 also as part of Slack. You remember we were using it for neighbor discovery, router advertisements, router solicitations. Those items are dependent upon ICMP. But we also can look at it for basic messaging. So I think it was last Thursday when we did the lab on testing network connectivity. One of the things I was able to do is I knew when it said destination unreachable from when I pinged, that more than likely is a routing issue of some sort. So that I knew that simply because I know about networking, I know about what ICMP messages are. Time exceeded. Now, one of the things that a lot of people don't realize is that every time a packet goes through a router, as part of that going through the router, there is a time to live field, a TTL field in IPv4. It's a hop field in IPv6. But every time you go through a layer 3 device, that is decremented by 1. If it ever reaches 0, an ICMP time exceeded is sent back to the device. So here we have an ICMP echo request. This would be just a ping. So an ICMP echo request goes out, goes across. The host will then do an ICMP echo reply. Yes, I am here. And reply back with an echo reply. Now, one of the problems on the modern internet is that because ICMP can be used for reconnaissance for attackers, and it can also be used for pings of death and also other types of nefarious things on a security side, many networks do not allow pings to go in or out of their networks. So ping does not always work if you're trying to ping across the internet. So that's a little bit of a problem there. We can see too, if you ping certain things and get a destination or service unreachable, you may end up with a network unreachable, host unreachable, protocol unreachable, or port unreachable, depending upon which one of those are unreachable. And then our time exceeded field, which is again, when it gets dropped every time you go through a router, you get the TTL dropped by 1. And then we talked back about Slack, stateless address auto configuration, IPv6, how when a device boots up, it sends out a router solicitation and says, hey, is there a router out there? And do you have a an actual message, or not a message, a prefix that I could use? So send a router solicitation. The router will send back an ICMP v6 router advertisement that says, yes, and I'm part of this prefix, and you can be part of that prefix too if you're set up to be using Slack. There's also neighbor solicitation messages. This is sometimes used for duplicate address detection. So in other words, I'll send out a neighbor solicitation once I pick an IP address, especially if I remember with Slack, the devices create a random IPv6 host portion to the address. So one of the things they do when they select that is they send out a neighbor solicitation message and say, does anybody have this address already? On the off chance that randomly two devices have created the same 64-bit host address. And obviously if it does, then the neighbor would respond back, say, yes, I do have that. It's also used a little bit like we would use ARP in the ARP. Hey, Robbie, welcome. Kind of like how ARP is used.
Thank you, sir.
In Ethernet. Okay. So it allows us to do the same type of thing here. It says, will you, whoever has this address, send me your MAC address, and then you get a neighbor advertisement that says, yes, that is me. That's my IP address. But also they can do it to do duplicate address detection. Now, ICMP is the basis for ping. So we send out a ping and that ping will get a response. If we ping our loopback, so in other words, one of the things we can always do, if you ping your loopback and it is successful, so I can bring this over here and I can ping 127.0.0.1, that will tell you that IPv4 is at least loaded and running on the machine. Now that doesn't mean you have an IP address per se, but many times that is what we do. We will first just ping to see if we've got it loaded. Then using IP config, you may try to ping your default gateway, 10.102.10.1 in my case. And that works. So now I can ping. And then we may try pinging a remote host. And I'm just going to take a wild guess and try 60.1 and see if that's out there. Nope, expired in transit. So there's nothing on 60. Let me think about 122.1. That should be there. Oh, trying to put too much on it. Yep. So I know that's another classroom. So I'm able to ping to a different network. So I ping from the 10.102.10 network over to the 10.102.122 network. So I went through the process of pinging the loopback, pinging the gateway, pinging a remote host. Most of the time, I actually just start pinging a remote host. And if that doesn't work, then I'll back down and ping the other devices. Now, here's where you're going to get in trouble, though. Let's try to ping google.com. You'll notice it resolves it. So DNS works. I've got my DNS resolution, but the ping does not work. Hey, Liz, I see you're coming in. Welcome. But the reason it doesn't work is because our campus network does not allow pings to exit the network and to come back in. So that's why this is sitting here just timing out or waiting, and eventually will time out, because even though I can resolve it, now this is one of the examples to where just because I can't ping it doesn't mean I can't get there. Okay, it's one of the few times because we've got an access control list that is blocking the ping. So again, we can ping the loopback. Now we can also ping, if we want to ping our IPv6 loopback, it's : 1. You'll notice IPv6 is loaded on this machine. So the IPv6 stack is loaded now. Again, not necessarily that I have an IPv6 address, but it is at least loaded. This means if you're in Windows, what this really means is it comes down to this. It comes down to inside of Windows.
Let me ask you one question, Kelly.
Okay.
When you use the ping for the google.com and then you get timeout.
Yep.
Can you use Traceroute? Because Traceroute and ping is the tools that they said that we can use to for reachability of the network.
Right. Let me do a Traceroute and I'll show you. Traceroute will show you where it stops at. So what you're going to see is you're going to see this. You're going to see it. Oh, TraceRT. I always do that, folks.
Traceroute.
Yeah, TraceRT. I always do that because I'm so used to being on a router. So notice what it's going to do is it's going to go to my default gateway of 10.102.10.1, or it should, yep. Then it goes down to this intermediate hop, which is on our network. Oop, Dr. Harrison must be having trouble getting on. And then it stops right there. So in our core of our network, we are blocking pings. And it will try to do this for up to 30 times. So what it does is it sets a TTL of 1, sends it out, you get that response. Then it sends a ping with a TTL of 2, gets the response. Then a 3, TTL of 3, and it'll go all the way down until it tries up to 30 hops on a Windows machine. But because we don't have ICMP working on our network, it'll time out. Now notice again, I told you about pinging : 1, which is our loopback. What that tells me is this. That tells me that under my adapter properties, IPv6 is turned on. See how it's checked? Now, if I uncheck this, click OK, I'd have to reboot my machine for it to take effect, more than likely, but we'll see. Let's try now. Maybe it will work. Oh, still working, because you have to reboot once you turn that off. Yep. Yeah, it won't automatically stop it without turning it off. But you could actually turn off TCP IPv or TCP version 6 or IP version 6, and that would allow you to stop pinging to that. But you'll notice if I can ping : 1, it means that's loaded, and if I can ping 127.0.0.1, it means that inside of my adapter properties, I've also turned on IPv4. So IPv4 is checked. Dr. Harrison, did you get yours working? I noticed you were having some trouble. Sorry.
Yes, I'm having problems with my computer. It keeps rebooting on me.
Oh no, that's not good.
Yeah, I know. But I think I'm in for a while.
Okay, welcome. One thing I will tell you folks, in our labs, anytime if you put static IP addresses on, make sure, I've had a couple labs that people are having trouble with, and I think what's actually happening is inside of the lab itself. So like if I go in here, let me go back to my net lab because I got a lab going on, so I can go in here. So if we go in this PC, if you go into this PC to change its IP address, okay, so I go in here, go to Ethernet, change adapter options, and I go in here and double click, and I put, 192.168.12.10, and I do. If you don't click OK, it does not get applied. Also, I've seen it to where, even though I clicked OK there, let's go look and see if it got applied. See how it still has not been applied, even though you click there, because you've got to click OK on the Ethernet properties. If you don't do that, it's not applied on the actual interface. So make sure when you assign the IP address to the device, make sure you're clicking OK twice. Otherwise, it will not be assigned. That's something that inside of Packet Tracer, yeah, it's automatically done. But on a real network, it's not that way. So you need to be able to go in here and go, okay, I'm going to put an IP address on here, go to properties, double click on TCP IP, statically assign the IP address 192.168.1.11 or 1.2 is what one of them is. We could put a default gateway if we wanted, but we don't need it in here. But if I click OK there and stop, you will see it does not get applied. Okay, so you had to click OK to close that window, and then now the IP address has been assigned. Should have been. There it goes. Yep. So 1.2 is assigned. I think some folks are having troubles in net labs because they're forgetting to click OK on that second dialog box when you change your IP address. Anybody had that issue?
Yes, I do, but I think after several times that I take note of it, that and I have to go back again and try to do it. And then, sometimes when you're walking and then you walking faster than in your head, and then you go back and you see that, okay, what happened? And
right. Yeah. And then you find that
troubleshooting it. Why is it not giving me what I want? Then you go back and say, I always start all over again to see where if I can find the fault among people.
And I do that. You'll actually find the dialog box still open. You're like, oh, okay, there it is. So make sure you click OK on this dialog box once you've changed the IP address inside of there. Very important. So again, here's setting dynamic or static IP addresses, pinging remote host. So you notice you can ping across the remote host. Remember what the router does is a lookup to find the destination network and send it over. And then hopefully that device will come back with an echo reply. Okay, so that is a ping, just a normal ping will give you reachability to a device. Traceroute is used to test the path to the device. And again, remember, traceroute and ping probably will not work across the real internet, simply because most networks are blocking them. Okay. So I did make a statement earlier. Everybody, we do need to make sure we're doing our labs inside of NetLabs. So if you haven't started doing those, make sure you get in there and get started on those. We've got about a month of class left. So we're getting there, slowly but surely. Questions on ICMP. I call ICMP just the messenger of the protocol stacks. So if you need a way to kind of describe it to your students, it's a messenger that is used for reachability and for traceability of pathing. Questions about ICMP, install in Internet Control Message Protocol.
Mr. Kelly, can you?
Yes.
I want to ask you another question.
Okay.
Why is the subnet so important than IPv4?
Why is subnetting so important in IPv4? Because of the fact that we have, when you think about networks, when you think about IP subnetting and IPv4, when you think about what we have realistically, okay, if we work with RFC, remember our IRC 1918? Okay, so what does RFC 1918 refer to? Anybody? Anybody remember? Remember, this deals with our private IP addresses, right? This defines our private IP address ranges. All right, so remember this was 10.0.0.0/8. All right, and it was also 172.16.0.0 to 172.16.255.255, and then 192.168.0.0 to the network 192.168.255.255. Now, from these two ranges, we typically use a /16, and here we use a /24. So here's why subnetting is so important. Almost every modern network on the inside uses an RFC 1918 address. This is one network, so it's one network of 16 million hosts. Think about that. That is a useless network because nobody's going to put 16 million hosts in a single broadcast domain. We have to subnet it to make it useful. Likewise, this is up to, that should be 31, not 16, 31. This is up to 15 subnets of /16, but it's 65,000 hosts on each one. And then this is a little bit more useful because we could use 192.168.0.0/24, all right? And so that's one network of 254 hosts. So we don't really have to subnet that so much. How many modern networks only have 254 hosts? If it's an internal network, like a small business, like my wife's business, maybe. But even there, I'm using two networks because I want to be able to have the wireless clients on a different network. So the reason subnetting is so important is because with the addresses that we use, which are the RFC 1918 addresses, you must subnet them to fit almost every network in existence. That's why it's so important. You will not find very many networks that are not subnetted in some form or fashion, unless they're extremely small networks. So for instance, great example, your home. You probably have at your house just 192.168.1.0/24 or 192.168.0.0/24. One of these two networks are probably on your home network because those are the two most commonly used internal addresses for Linksys devices. I don't even know if Linksys exists anymore, but the Linksys devices and the Belkin devices. Those are the most common two in use. It's also one of the ones used now by Orbi. Orbi uses these, which is a special wireless system. So that's the reason why subnetting is so important. Every network has it. Does that make sense?
Yes, yes, yes. You know, I had to do research into it, go back and read the textbook, and then just trying to get because we're talking about IPv4 and then subnetting. That one make sense to me now. How they see the 1918. So.
Yep. And the more you can read about subnetting and the more you can practice it, the better you will be. The better it will be because it just takes tons and tons and tons of practice. Now, I want to go ahead and talk about, remember our OSI model? We talked about how two devices, so we got a server here talking to a happy little host over here, okay? So these two are talking to each other. So when I send a request, so I'm requesting a web page, remember I've got information that's data, so it could be an HTTP GET request. I'll put an application header here, and then all of this becomes data for the session layer, and we put a session layer header here. Okay, so there's session. Presentation, not session, presentation. And all this becomes data for the session layer. Oops, data. My handwriting's really bad today, folks, for some reason. And then right below that, we've got the transport layer. Okay, so we got a transport header. So this is our transport header. Well, one of the things about the transport layer is that we have protocols at the transport layer. We have two main ones in IPv4 and IPv6, and they are the transmission control protocol, TCP, and his unreliable little brother, UDP. Okay, so whichever one of these is in use at layer 4 of the OSI model is going to determine how the application deals with traffic. TCP is guaranteed delivery. It's reliable. It does retransmissions. It does segmenting. It does windowing. UDP is a best effort. It doesn't care. It tries to get it there, but it doesn't really make sure it gets there. So as we go now on to the actual curriculum to look at layer 4 of the OSI model, the transport layer, we're going to look at TCP and UDP. And we're going to look at how that data is used. So here we have again. Now they're not showing you all 7 layers of OSI model. They're showing the 4 layers of the TCP/IP model. So the transport layer here, the protocol picked will determine how the application deals with information sent to it. So the transport layer is responsible for tracking individual conversations. So right now, imagine, let's think about what's going on my PC. I have a web page open to Netacad. I also have this Zoom session open. So I have another session going to Zoom. My email is open. So I have an email. So I've got all of these conversations going on. My machine and those machines that are responding to my requests must have a way to keep up with those. That is through the use of TCP or UDP and this tracking of individual conversations based upon what's called ports at layer 4. For instance, connecting to a web page, I'm connected to port 80 or possibly port 443 if it's HTTPS. This same layer is also responsible for segmenting data. So taking those big pieces of data, breaking them into smaller segments. That's important. So if you have to retransmit, you don't have to resend these huge, huge segments. It's also important because it keeps up with the segments so you know when one's lost, which one to resend. It adds in header information. It identifies the application. Again, port 110 with TCP is POP. That is email. Port 80 is HTML. Port 531 is AIM, or internet chat. AOL Instant Messenger in the old days. So looking here, we can see at the different protocols at the application layer and what protocol they use at the transport layer. TCP is used by FTP, HTTP, and SMTP and others, okay, like POP. POP is 110 TCP. TFTP, Trivial File Transfer Protocol, uses UDP. Anything that is like a video conferencing would use UDP. DNS is one of the weirder ones because DNS uses TCP if it's two DNS servers talking to one another, but it uses UDP if it's a client requesting DNS information from a server or with certain types of server-to-server communications. But most server-to-server communication is TCP based. Notice both of those ride on IP at the internet layer, okay, at layer 3 of the OSI model. But those are two possible layer 4 protocols that we use. Questions about those? So TCP, reliable, guaranteed delivery. In fact, you remember when we talked about the OSI model, we talked about the transport layer, we talked about reliable delivery. Well, the problem is, again, remember the OSI model is a reference model. It's not an actual protocol stack model. In the actual protocol stack model of TCP, they needed a way to do reliable guaranteed delivery that would slow things down because of the reliability. They also needed a way to send things quickly without retransmission capability, and that's why they came up with UDP. So it seems like TCP/IP breaks the model, but it doesn't. It just doesn't comply exactly with the reference model. It's a true protocol stack model. UDP, best effort. Now, the way we look, the good way to analogy for your students is TCP is like a certified piece of mail. You have to sign for it that it got there. UDP is like regular mail, like a postcard. You just stick it out there and hope it gets there. It might not. Now, you can do error checking, reliability, all of that with an application that uses UDP, but you've got to do it at the higher layers. In other words, it's got to be built into the application. It's not built into the layer 4 protocol. So you'd have to have some kind of checksum that's being run by the TFTP application, not by UDP itself. So which one do you pick? It depends. If you need guaranteed reliable delivery, TCP. If you need speed, UDP. UDP is all about speed because it has low overhead. Questions about that? All right. So we'll look at TCP and then we're gonna call it a day after that one. But let's look at TCP establishes a session, an actual session. And it does that. Here you'll see the TCP header. There's a source port for the communication and a destination port. There's a sequence number so that all these pieces of information are getting broken into segments can be reassembled correctly. There's an acknowledgement number, an ACK number, and then all of these control bits and other items that are in here. So we'll look in the control bit, we'll talk about the different flags, the 6 flags that are there. Some of the different applications that use TCP, again, HTTP, HTTPS, FTP, SMTP, SSH, and all of those right on top of TCP. UDP, look at how much simpler the header is. Look at the difference in those two headers. This should show you immediately why UDP is so much faster. Look at how much has to be processed in this header. Every one of these has to be processed by the device when it looks at a TCP header. UDP, very simple header. Source port, destination port, checksum, that's it. We hope you get there. So it's much quicker. Applications that use it, DHCP, DNS, SNMP, Simple Network Management Protocol, TFTP, Voice over IP, and video conferencing. All of those use UDP. So I'm actually stop right here. I want you to take away from today's discussion two things. ICMP, Internet Control Message Protocol. ICMP is the messaging. So ICMP is the messaging protocol for IPv4 and v6 for communications dealing with the actual devices and discussing layer 3 reachability. TCP, the protocol, is reliable delivery. UDP, remember, UDP is TCP's unreliable little brother or sister. Okay, those are big takeaways for today. Any questions about anything we went over? Any questions about NetLabs, about where we're at? Like I said, we're a month out, so if you have not been doing labs on NetLabs, please start. I had caught up with, I think, all the grading for this class last week, so I got a little bit more to do now. If you need anything turned on, the final exam, if you're in the position to want to take that, please do. You also need to remember that when time comes to take the written or the hands-on final, in this reservation, so that's available to another student. The hands-on final is a lab reservation inside of your class. So you go in here and you pick your class, and it's right there, the skills assessment. That is the hands-on final that has to be done inside of NetLabs. You can schedule up to 4 hours. It should not take you 4 hours, but you can schedule up to 4 hours if you need to do so. But that is the hands-on final exam. You will not be able to move forward to the next class if you do not complete the hands-on final exam successfully, because that is something that I pretty much hold sacrosanct, that we have to get you through that. Now, you do have the option to have multiple choice chances if you need them, but I want you to be able to do those hands-on labs so that you're able to give those skills to your students. Okay, I'm going to stop sharing. Any questions at all about class?
The last 3 items that you talk about, I think when we use the Wireshark, and then when we do the Traceroute, and then the packet tracer, and we do the simulation, we get some of those readings on it. We get the UDP, ICP, and
yep.
Then so that is when I observe when you do the simulation in the
yeah, and if you have a lab that's giving you trouble, remember we can do it in class on Thursday. Just let me know which one it is if you can before class, so I can kind of prep. I mean, I don't have to. If you've got one you just bring to class, I can do it too. But if I can prep before class a little bit for it, it helps. But if not, just come on Thursday and bring a lab that's giving you trouble, and we'll do everything we can to get you to understand it and to know what's going on. Okay. Any other questions? I'm going to stop the recording so you can ask any.